Hello everyone. I hope you all are doing great and enjoying your summers. And I did like to welcome you all in the amazing workshop of Web3 Init. So Web3 Init is India's largest month-long hackathon with awesome swags, networking opportunities, prizes worth thousands of dollars, and yeah, memories as well because hackathon without memories are useless. So also we have a surprise for you. Yeah, we are giving away GitHub swag. So do check out our Twitter for the same and participate in hackathon and win awesome prizes and swags. So let's start. So today we have Sanket with us. He's working as a software developer at Tezos India, and today he will guide us on how we can create a smart contract on Tezos using Smartpy. And we will take some questions of you folks if you have any in the end. So, Sanket, would you like to introduce yourself?
Yes, hello. My name is Sanket Nighot, and I'm working with Tezos India, and uh, also I'm working on my projects such as Game Geeks and Paper Finance. And like I have a experience in blockchain development for around 2 years now, and yeah, I'm developing on Tezos, and yes, that's my intro.
Yeah, awesome. Yeah, we can start with presentation now.
Okay, sure. So just confirm once my screen is visible.
Yeah, now it's visible.
Okay, so a general introduction to traders we are going to do in this yeah, I introduce myself I have founded two projects, Game Geeks and Paper Finance. One is in gaming sector, and other is a DeFi project which I'm working on. I started my blockchain journey in Tezos India Fellowship 2.0, which was 2 years ago, and after that I'm working as a blockchain developer and mentor with them. And yeah, so today's agenda will be like introduction to the Tezos ecosystem and like writing our first smart contract on Tezos using Smartpy language. So like we will be like going through each and every step here right now, like what Tezos is actually and like how we can develop smart contracts over Tezos. So yeah, so let's start with what is Tezos and why Tezos. So initial problem with other blockchains which we have, not all, but most of the blockchains we have is like hard forking. Like if you want to upgrade any blockchain or like if you want to give add some functionalities to it, you need to hard fork the blockchains. Like in the sense, like you can see here, there is block one, block two, and if you want to like add some functionalities, there are the old blockchain is different and the new blockchain has the different blocks like block 3, block 4. Like this is a very big problem in existing blockchains such as Bitcoin. Like Bitcoin has notable three forks you can see currently. Like three what happens in these forks is like the community gets divided into these three forks. For example, there are some people who don't agree with the new functionalities or new features that are added to the blockchain, so they like to stick to the older blockchain and they keep working on it. And like the ones who have accepted the new changes, they work on new blockchain. Due to this, what happens is like the community gets distributed, and there are two or more or notable forks on the blockchain. This is the existing problem which blockchain has, most of the blockchain has, and Tezos is solving it with like a proof of stake based blockchain that evolves. What I mean by evolves is like for example, you can see until block 224460, there was a Hexenhow protocol which was working on the blockchain, and there was a like protocol shift in flight protocol upgrade, which we say shift from block 44608 to 4609. And what happens is like from 4609 block, the new protocol Itaika will start. So this will have a different functionality or different upgrade or different feature which will be added to the blockchain, and due to which like there is a single blockchain which is running from starting to end. And you can see like there are multiple changes that are happened to the blockchain up till now. So starting there was Athens, which was the first version of the Tezos blockchain. Then there was Babylon, then Carthage, then like in that manner Jakarta, and after Jakarta also there was Kathmandu, Lima, and now the Mumbai net will be like launching in a month or so. Like this will be like 12th upgrade of the blockchain. And yeah, so like you can see on the screen like which were the different upgrades in the blockchain and what were the notable changes which were made in that protocol upgrade. And yeah, like this is how Tezos solves the problem of forking, and like there are no forks up till now which are happening on Tezos. There is a single blockchain running from 2017 till now. And yeah, so this is how the governance periods works in Tesla. So there is a proposal. There are like number of people, they send their proposals in the Tezos ecosystem, where the proposals are then explored by all the community members. And when the proposals are explored, there is a cool down time where people vote for the proposals which are best suited for the blockchain. And when the best suited proposal is like chosen, then they are like tested on the test nets, like test uh, people in the ecosystem test these whole changes, and in this cooldown period vote, and then they like test the all things. And after that, once again there is a voting period. In that voting period, like people vote for the blockchain to get adopted and all. So when the uh, some proposal is accepted for the adoption, then in the promotion stage the all the like protocol upgrades, software upgrades are done by all the miners or bakers, which we say on Tezos. And when this is done, the adaptation phase occurs, and like the blockchain gets adapted to the newer protocol, as you have seen in these upgrades. So like all these upgrades up till now has gone through all these changes and all these periods, and these periods like run for around 2 to 3 months. And like in this period all these things have been like checked, and then the upgrade works. What happens if the proposal is rejected? When the proposal is rejected in any of this phase, then again the new proposal period starts. The new proposals are accepted from various uh, people or uh, various organizations working with Tezos, and then the same uh, things are followed. For example, exploration, cooldown, like all the steps are followed again if the proposals previously uh, submitted are failed. This is how the governance period works. Now, Tezos uses liquid proof of stake for all these things. So, what is liquid proof of stake? So, what happens is like there are bakers who bake the blocks and add it to the blockchain. So for being a baker, you need to have 6,000 days to be a baker. So there is not possible for everyone to be the baker, right? So what Tezos provides is like you should have minimum 600 days, and like rest 5,400 days can be delegated by the users. Like for example, I am a user, but I don't want to be a baker, then I can become a delegator. So what I will do, any Tej I have in my wallet, I will delegate it to any baker. Like for example, here it shows ever stake. So you can delegate your all Tej to the baker. So when you delegate it, the Tej will not disappear from your wallet and go to them. It will stay in your wallet, but like you will get rewards out of it. So what happens is when baker, for example, Everstake will bake a block now, and if after baking a block, he gets 5 XTZ or 5 days as a reward. So what he will do is like out of that 5 days, some percentage he will keep for himself, and other he will distribute around amongst the delegators who have delegated that days to them. And what's more advantage of delegation to Everstake is like more number of delegation, more chances of them to be mining a or baking a block. This is how liquid proof of stake works. So most used terms on Tezos are like Baker, or as I said, the person who validates becomes a validator, similar to miner on Bitcoin or Ethereum. One who validates the blocks on Tezos or bakes the blocks on Tezos is one called as Baker level. Alternate name for blocks. So like first block is like level 0, then second block will be level 1, then level 2, level 3. That's how level works. Then third is Tez. Tez is a unit of currency, like similar to Ethereum, Bitcoin, BTC. That's a Tez which we use for Tezos. Mu-Tez is a micro Tez, like 1 million Mu-Tez is equal to 1 Tez. This is like a second conversion. And like XTZ is commonly used ticker symbol for crypto exchanges. So like whenever you go for on Binance or Coinbase or any other crypto exchange, you will see XTZ as a symbol for Tezos. On that, it's called as a ticker symbol. Another problem is smart contract changes. Like for example, if you take the EVM code, you can see like in this code, you will not understand what the smart contract is. Like this is the compiled version of the smart contract written on EVM, but you will not understand what's written here. So that this low-level languages, the codes are not readable properly. So like if you want to find some vulnerabilities in this, it's very hard. Like for example, not all the projects working on the blockchain reveal their actual smart contracts written in the high level languages. So for every user, low level languages are available. But what happens is even with this low level bytecode is not readable for a normal programmer. But when you check for Tezos, so like this is like a low level code which Tezos generates, which is written in a Michelson language. This is very basic to machine level code, and like this is very like a it has better readability. It's strongly typed, and like for formal verification, like you can understand what is written in the code and what operations are being done here. Like this can and these codes are generated from high level languages. Like for example, in Ethereum, when you write code in Solidity, it's get converted into the EVM based bytecode as we saw here. In Tezos, what happens is when you write in high level languages like Smartpy, Lego, it gets converted into the Michelson code, which you can see here. Like the high level code language are like there are two examples, Smartpy and Lego. There are more such examples, but like these are the basic examples we are going giving here, and they get compiled down to the Michelson language, which we saw here. So when you write this code, when you compile down, it will be converted into such similar type of Michelson code. And yeah, the structure of smart contracts on Tezos. So basic structures are like ops concepts which we use in general Java, Python, and all. There is like a class, constructor, and functions. Similarly, there is a contract which we start with. There is a storage of that contract and the entry points. We will be like seeing it ahead, like how this works, and we will be writing a short smart contract for that as well. Yes, moving ahead, we will start writing a smart contract, basic smart contract. So what we will be making today is a small lottery smart contract on Tezos. So let me explain the functionalities which we'll be implementing in this smart contract. So what we will do is like there will be uh, a contract which will accept users. There will be like a number of tickets which will be provided, so users can buy those tickets and for a certain price, and at the end of the contest a random user will be selected, and that user will get all the reward prize that is collected in the smart contract at that time. For example, there are total 5 tickets available for purchase. Alice, Bob, John, Mike, and Charles, each of them uh, buy one ticket. Then at the end of the contest, a smart contract will generate a random person, and that person will get 5 days. For example, Bob is selected. Bob will get the 5 days. This is what we are going to implement in the smart pi. So now let's move to the uh, editor. This is like a basic SmartPy ID, which you can see. If you want to like access this ID, you can go to smartpy.io/id, and like you can start coding out there. You will get a similar overview. Let me go through the editor first of all. So here is a toggle for light and dark theme. You can toggle it. Then there are language selection bar here. This is Python, this is TypeScript, this is OCaml, and this is Michelson. So these are 4 languages in which you can write smart contracts on this IDE. So this is a editor tab. So the currently we have opened the editor. This is the editor tab. Explorer is the smart contracts documentations and all. You can go to Explorer and you can get all the documentations are all written there. Wallet is a Smartpy wallet which is been given by Smartpy itself, or you can also use different wallets if you want, and help you have additional documentations and articles which you can use. Then there is a settings tab where you can like adjust your layout and font size and all. Then you can share your code also, or you can operate it on IPFS and share, or you can directly share the embedded code. Then in tools we have load from disk or download from, if so like if you want, if you have smart contract written somewhere else, you can load it using this function. Or other download from the contact disk is like the content you have written here that can be downloaded to the disk. Download output panel is like when you generate the output here, you can download the output as well. Then when you go to tab, you get a number of templates which you can refer to whenever you want. There are simple smart contracts like how to store a value, a simple calculator, the first in first out data structure, how it works. Then there are some complex as well, complex smart contracts as well, which you can refer them. Then there are reference teams and all, you can add them to favorite. Then yeah, coming here, run button is for running a contract. When you write a contract and you want to test, you can run there. Target is like there are when you write test, at the end we will be writing test for the smart contract as well. So when you write multiple tests, you can say the target test from here, and then you can run the contract, and it will be like then shown here. The output will be shown here. And this is the clear outputs button, which will like clear the outputs if you have any. Then when you come down, when you click here, there are you get three options to list the stored content. So if you have some other contracts I have made, you will get listed out here. Then edit contract is like you can edit the name of the current contract, or delete the contract from here as well. And then there's create a contract. If you want to create a new contract in the this editor, you can create here. So whatever contracts you create here are like storing cached memory in your computer, or your PC itself. And whenever you will open this ID on the browser, you will get the contracts that are saved here instantly. So yeah, so let's start with coding the smart contract right now. So first thing we will do is like import a smartpy library. So basic syntax for that is like import smartpy uh, as sp. So SP is like a term we should be using all over the contract. For that, we are using as SP, like we are giving an alias to the SmartPy, rather writing SmartPy all over there. So we'll be importing SmartPy as SP. Then the second thing we'll be doing is like creating a lottery class and inherit sp.content in it. So like we'll be creating a class called as lottery, and we'll be inheriting the sp.contract. So what does is like this will help you create a inherit the class called as content that is itself in a smartpy library, and that will help you like compile the code and generate the Michelson code that will be deployed uh, on the blockchain later. We will also see that. So after we create a class, then the second thing which we'll be doing is like initializing our storage. So storage is must for a blockchain. So every contract will store some data. So for our smart contract, we will be like storing a map. Mapping is like just a basic JSON structure with a key value pair that will be having the players data, which are purchase our tickets. The second will be the ticket cost that will be there in the contract. Then third will be available tickets, like how many tickets are available, that will be written, and the max tickets. So like how many maximum tickets can this contract have. This is what we'll be like having it here. So let's start it. First we will like define init. This is like a basic smart contract code. So like this, we are initializing the first like we say constructor in OPS, like object oriented programming language constructor. In the same way, we are like defining our uh, first storage. So in this self dot init, yeah. So this is our storage. So what is the first thing we want? We want to store the data of players. So for that, I will give the name players, which will be equal to map. So for writing a map, there is a syntax that is like we will be like telling what type of data structure the key has and what type of data structure the value has. So this is how it is written, that sp dot map. So you can see like initially the map will be empty. So we will like denote it by empty string, and then the T key. So T key will be a number. So number is like a positive integer. So positive integer is like denoted by sp dot t net. So you can see here like I used map here, map sp dot map and sp dot t net. So what is different between this? So like what sp dot map is like directly defining a map, and sp dot t net. So when you write a capital T and a capital initial of the any data type after SP, it denotes that is the data type. So like for example, actually writing a string and denoting it as a string in JavaScript in that manner. The second thing will be like a value, like T value, that will be SP dot T address, right? So these two things will be there in players uh, mapping, which will be storing. So what we will be doing, like whenever the user creates a ticket, we will be like checking the length of this map. Once we check the length, that length we will assign that as a key, and the value will be the address of the user. Okay. So once this is initialized, then second thing we want to initialize was the ticket cost. So ticket cost will be in the Tez. So as we are on Tezos blockchain, the ticket cost will be in Tez. Ticket cost is equal to sp dot net, and let's say sorry, sp dot test, and let's say the ticket cost is one test. So that will be one test, like if you want to purchase a ticket of current lottery, then one test will be what you will be charging for one ticket. The second is tickets available. So currently how many tickets are available? For that we will be writing sp.net, and for example let's say five tickets are only available right now. Then max tickets is how many maximum tickets can be there for a single lottery. So max tickets, let's say there will be five, because no player has five right now, and total tickets are five. So max tickets will be five whenever a new lottery begins. Yeah, so this will be our basic storage. Oh, sorry, I guess this should be here. We are initializing our storage here. Okay, step three. We have initialized our storage. Now, next thing we will be doing will be uh, writing an entry point to like buy a ticket from the blockchain. So whenever you want to define an entry point, if you like just write a function like buy ticket, and if you like just write this function buy ticket, then like you start writing the code about it. The smart contract will smart pi will not identify this function as a entry point. So to identify this function as an entry point, you will need to write sp dot entry point. So what will this do is like this decorator will tell the smart pi that the next function which we are writing is a entry point, and the user can like interact with it. So if I will not write this entry point here, then user will not be able to interact with this entry point at anytime. So what we'll be doing in buy ticket is like first we'll be verifying that the tickets available, which is written here, tickets available are not equal to zero. That should be greater than zero. And then second thing we'll be checking is like has user sent us the ticket cost. So if these two things are right, then user can like buy the ticket, right? So like first we will verify that. So sp dot verify. First we'll verify if now we want to access this data, right? So for that, what we do is like self dot data. When you write self dot data, this whole data can be accessed. But we want to particularly access the tickets available. So what we'll need to do is self dot data dot tickets available. This will verify if now this will like fetch the data of tickets available. We want to check self dot data dot tickets available are greater than zero. Okay. So what this will do is like this will check if the tickets are greater than zero, and if the tickets are greater than zero, it will go to the next line. The code will be compiled and it will go to the next line. But if it is not greater than zero, then we need to display some message to the user that uh, tickets not available. Okay. So this will display to the user that tickets are not available. Yeah. The second time we will be verifying what has user send us one page. So what we will do is like we will like check the ticket cost and has user send us that. So how we check that user has sent us the correct amount? So for that we have sp dot amount. Amount should be equal to self dot data dot ticket cost. So this will check that the data sent by user is actually equal to the ticket cost, that is one page. And if it is not, so we will write invalid amount. This is how we will verify it. Then the next steps which comes after this is like if these two things are met, right, then we will add the player to the our place list, and like we will decrease the available tickets by one. So what we will do here is like self dot data dot players, and in this uh, sp dot length of we will check the length of players. So we will check that length, and that length will be currently it will be zero, right? So if this player gets added, the length will be one. So when the next player will come, his number will be one in that way. So self dot data dot players, and that will be equal to the user. So that will be sp dot sender. So what will sp dot sender do is like it will add the address of the user to the contract. Okay. I hope everything is clear up till here, and if there are any doubts, like please let us know. We will like clarify all the doubts. The next thing which comes is we need to decrease the ticket available by one. Okay. So what we will do is like self dot data dot tickets available, and that will be equal to now here we need to do a small mathematical calculation. So we need to like check the data never goes like there are some checks which are done behind by the Smartpy as well. So we need to write like sp dot as nat, and in that what we'll do is like self dot data dot tickets available is 1. Okay, so this will like ensure that the value is always nat. What nat is like positive integers. A positive integer is what we call as nat. So after this thing is done, we have like decreased ticket by 1. We have added the player, and now yeah, this is what will be done, right? So let's like run and check. Yeah, we haven't wrote any test cases as of now. So in that's why no nothing is shown up here. So our one entry point is done. Now second entry point which we will be writing is end game entry point. Similar thing we will do at sp dot entry point defined end game, that we have self, and yeah, what we want to verify here, end game, we want to verify that tickets available should be 0. So all the tickets should be sold out. After that only anyone can call the end game entry point. So sp dot verify. What will verify? Self dot data dot tickets available equal to 0. If these are not available, so we will write it like game still uh, still running. Like game is still running and you cannot end the game right now. That's the message will be like showing. Once this is verified, we need to pick the winner now, right? So we will need a winner id, right? So winner ID. So how we will be picking the winner ID here? So what we will be doing is like we will get a timestamp, current timestamp from the block. Timestamp is like the unique stamp which every blockchain uses to like calculate the time at current time, and at that time, and like we will like take a modulus of it using the max tickets. So what this modulus does is like it divides the number by the max tickets, and the remainder is the value which is stored. So this will like help us get an integer, and that we will like use it as a winner. That so this is like a slightly random number which we'll be getting. So sp dot as nat will be writing sp dot now. Sp dot now, what we'll do is like this will get a current time. So now we just we want to convert sp dot now is like sp dot t timestamp. This is the what we say. This is the data type which we sp dot now has. Now we want to convert it to integer. That's why we use as net here. So sp dot now minus sp dot timestamp. Let's say we will take it as 0. So this will help us compute the timestamp, and like we will take modulus of it, and modulus with self dot data dot max tickets. So this will always generate winner ID from 0, 1, 2, 3, 4. This total 4 IDs will be generated, and that will be stored in winner ID. So after the winner ID is fetched using this, the winner address, we will then like fetch the winner address. So how will fetch the winner address? Self dot data dot players in the bracket winner ID. So this will like fetch the winner address and like store it in the winner address. So now we need to send this data, send the total amount to the user. So for that we will like use the function called as sp.send. Uh, what we will do, sp.send. You can see here the send function is a destination and the amount. So in the destination, we will write the user winner address. So winner address and amount will be sp dot balance. So what this balance will do is like sp dot balance is something like total balance of smart contract. So when all the five users have been played, the balance will be five days, and that all total balance will be sent to the uh, winner address. This is how sp dot send works. So after this is sent, what we want to do is next. What we want to do is we want to reset the game. So to reset the game, first we need to like reset the total players and the total tickets available. Okay. So for that, first we reset total players, right? So self dot data dot players players will be equal to empty array, empty map that we like shown it before. So this is how it will be shown. And yeah, so this will like delete all the previous entries. And second thing which we will do is like tickets available will be equal to 5 again. uh, that will be done like self dot data dot tickets available equal to self dot data dot max tickets. So like this will like help us like this will help us get the max tickets available for that lottery that time, and it will like assign that value to tickets available again. So yeah, this is the end game which will be like working. And now next thing which we'll be doing is like writing the test for these two end games. So first we will need to write test. So at sp dot at tests. So this is help. It is a decorator which tells the Smartpy library that we are adding the test from here, and we need to give them a name. At is at test, and the name will be, for example, main. These are the main test which we are doing. So let's say the name is main, and then from here we will define the test which will be writing. Okay. So define test. Let me take it up. Okay. So let me explain the flow here. So first we need to create the scenarios. Scenarios are the test scenarios which Smartpy uses, which will tell that what will be like the how the Smartpy test will go on. Like we'll add the test to that scenarios, and that will display us on the output. So let's first initialize it sc. Let's call it sc is equal to sp dot test scenario. Okay. This is how we will be calling the test scenarios. And like we will need some users, right? So like let's initialize some users first. Then let me try here. Initiate user accounts. Okay. So here will be like writing user accounts. Let's say first account is admin account, which will be is equal to sp dot test account, and we will give that name as admin. Okay. And we will need some similar accounts. For example, alice is equal to sp dot test account, and the name of the account will be Alice. Then Bob sp dot test account Bob. Then next will be let's say Elon dot test account Elon, and let's say Mark mm, P dot test account sorry dot test account and Mark. Okay, so like we got our five users here. We'll be using these five users, and then yeah. So we will need to like add the contract here. So let's say contract is like lottery is equal to we will be calling this contract lottery here. Hello, lottery. So yeah, this is initially we initialize the contract and we need to add this contract to the scenarios. So we have our scenarios here. So sc plus equals lottery lottery. Yeah. So what this will do is like this will add this lottery contract to the scenarios. So when we run this, if there are some issues errors that will be shown us. For example, this was test missing one position argument self. So I might be missing some argument here. Okay, this self is not needed here. Okay. So you can see that error comes. So what is the error? Missing field tickets available in type this. So line 36. I didn't get the error. Oh, missing field tickets available in type max tickets player ticket cost tickets available. Tribute error. Okay, there is a typo. Tickets available. Yeah. So when you run this, yeah, okay, the contact, so there are no errors now. There was just a typo, and the typo is like covered, and yeah, the contracts now compiled, and this is the compiled contract which you can see here. The Smartpy library compiles this contract, now you can see like here I have winner ID and all written in separate variables that contract will compile it indirectly use it in the contract, and you can see the deploy Michelson contract. So when you go to deploy Michelson contract, you can see the Michelson code also generated out here. This is the Michelson code of similar contract which we have written here. So this is how a contract gets compiled. But now we need to like check the data. Okay. So if we write the test scenarios here, so first thing what we will do is like in the test scenarios we will write test scenarios to like buy tickets. So uh, c.h1 like this is a normal HTML I'll be uh, using buy tickets test. This is like a basic HTML I'll be using here. These are like HTML tags you can add in the output panel for better visibility. So sc plus equals is equal to first we'll be calling buy ticket. Okay, buy ticket. So for that, uh, when I call the buy ticket, then I will need to specify some things like who is calling it, and how, what is he sending, what data is he sending, and in that manner. So for that we will write dot run, and in this run we'll specify that he wants to send amount, the sp dot amount which we like specify that amount the user wants to send, and that amount is sp dot test one. Okay. The second thing is he wants we want to specify who is the sender. The sender will be from, for example, admin. So admin dot address. So uh, when we create a test account, there are like four things which are created: private key, public key hash, and the address. So from that we will be using address thing, and that will be sending out there. So we are sending amount, we are sending the sender, and the these two things will be used to like create the first buy ticket for admin. So when we run this, buy ticket is not okay, sorry, a lottery dot buy ticket. I forgot to specify the contract which we are like using, lottery dot buy ticket. And yeah, yes. So this is the HTML tag which I used, H1 tag. There are others also, H2P, that is paragraph and all that you can use. You can see the transaction here. The buy ticket was called, balance is one test because user sent one test to the contract, and the operation you can see the max tickets are 5. The player is added to key 0 with its address, and then ticket cost was 1, which is already stored, and not available tickets are 4 because one ticket is purchased by this admin, and the available tickets are 4. So like we can simulate similar test for other 4 people. Let's say we just need to change the sender. There will be Alice, then Bob, then Elon, and then Mark. So all 5 tickets will be used here, right? So you can see that first admin bought, that time total tickets available were 4. Then second was bought by Alice, then the tickets available are 3. Then it was bought by Bob, then tickets were available to, then Iran bought it, then Mark bought it, and then there are 0 available tickets. So what will happen if after this someone tries to buy the ticket? Let's try that also. Plus equals, let me paste it directly, and let's say admin is only buying it, but it should fail, right? Because total all tickets are over, and now this should fail. So we add one more thing to tell Smartpy that this should be valid false. What this tells that this should not run. So this, when we run this, the transaction the output comes correct, but when you come here it says that tickets not available and the transaction doesn't happen here. What will happen if this I don't write this? If I don't write this, Smartpy will throw an error at me that there is error in scenarios. So for that to run all the test, valid should come there. Okay, so this was basic how to buy tickets. Now the last one is end game. Okay, sc dot h1 end end game entry point, end game test. What will happen in end game? Lottery dot end game, and we will be calling it. Let's say dot run. Let's say sender is admin. Then we will need timestamp. For that, now is equal to sp dot timestamp. Let's say timestamp, initially timestamp will always be equal to 0. You can see, I think here timestamp is always equal to 0. So we need to manually type the timestamp in the test, but when it's running on the blockchain, the timestamp is taken from the block itself. So for example, the time was the 20. Okay. So when you run this, you can see at the end endgame test case the time was 20, and according to 20 the winner will be sent 5 days transfer to the SFRS, because when you divide 20 by 5 the remainder comes 0, and in our list the zeroth key was SFROA case. So that it is transferred to this, well, this account, 5 days are transferred to this account. So this is how all works. You can like write more test cases here. So like this was the basic Smartpy introduction to you using this lottery contract, where we saw creating the storage, then creating entry points, writing tests, creating basic mathematical computation and all that, and verifying the test. So whenever you want to deploy this contract, just go to deploy Michelson contract and click here. It will take you to the uh, origination page. You need to like select the network. For example, GhostNet is a test network. Then you need to select the account. Then you will need to connect your account. Then all this data you directly you can like click on deploy contact, and contact will get deployed onto the network. This is how origination takes place. You can try it yourself later, and if you want to like extend this context, there are like some more things, like you can improve buy tickets and improve end game randomness more. You can like try it later, and like you can work on this content for like learning more things. And if you have any doubts, like just let me know, and like we can clarify our doubts here. Yeah, that's it from my side. And yes, one more thing. If you have any questions, please ask, and you can follow us on the socials here. Yes, that's it from my side. Thank you.
Yeah, thank you, Sanket, for such an amazing workshop. We got to learn a lot of things regarding Tezos and specifically Tezos in the itself. So, if you guys have any doubt regarding building something on Tezos and anything, you can directly reach out to Sanket on Twitter. I think Sanket is the best place to reach out to you. Might be all the developers will be active there. So before closing everything, I just want to remind you to register for the hackathon. And if you haven't registered yet, so just click on the link that I have shared in the chat. And yeah, we will be back tomorrow with some another great session. So thank you for joining us. So I'm just sharing all these links in the chat itself.